Problem 17. Let's read. What can be deduced from a table of wavelengths on the waves in the electromagnetic spectrum? Green light has a shorter wavelength than X-rays. Red light has a shorter wavelength than green light. The wavelength range for radio waves is less than that for infrared waves. The wavelength range for X-rays is less than that for radio waves. To answer this question, you need to understand the sequence. You have to have this memorized, the sequence of the electromagnetic spectrum and the range of wavelength and the range of frequency for each one of the electromagnetic waves. So let me take a look on this. So before going to our class notes, let's spot here what are the wavelengths that is each question is talking about. So question A is green light and X-ray. B is red light and green light. C is radio waves and infrared waves. And D is X-rays and radio waves. So pretty much we have a repetition here. We have X-rays, we have radio waves, we have infrared, and then we have green light, and we have red light. Another critical information, the options are comparing just the wavelength, not frequency, just wavelength. So a good strategy would be organize the options in wavelength so we can kind of compare them. If we organize those options in order of the wavelength, we know from this option that radio waves has the greatest wavelength of all, and the X-ray will be the shortest wavelength, which means that the smallest wavelength will be here and the largest one will be here. For our selection, the smallest wavelength compared with the longest one here. So the smallest one will be our X-ray, and the largest one will be my radio waves. And those three, they will be between them. So let's figure out the order. A great clue here, infrared and red, they go side by side. Comparing green light with red light using this diffraction grating here, the red light is 700 nanometer, and the red light and the green light is less. So the green light should be closer to the X-ray. Great, now we took care of the green light. Now the visible light, they stay together. So let's keep going with the next color that we have in this problem, which is red. So now this will be red. So what is missing now? The infrared. Infrared, because needs to be together with red. So now that we have organized the wavelength from our selection, from the X-ray to the radio waves, so the X-rays having the smallest wavelength and the radio wave having the longest wavelength. So now let's go back to our problem, read and find the correct answer. A, Green light has a shorter wavelength than X-ray. Definitely not. The X-ray is the smallest one. Option B, red light has a shorter wavelength than green light. No, because as moving this way, the wavelength is getting longer. C, the wavelength range to radio waves is less than the infrared. No, because the radio waves has a longer wavelength than infrared. Okay, so they save the best for the last. So the wavelength range for X-rays is less than radio waves. Correct. When I solve this problem, could I just go ahead and after explaining the wavelength from X-ray to radio waves, just mark D, because that makes sense. The wavelength range for X-rays is less than radio waves. Yes, I could, but I'm using this problem for reviewing with you the sequence of the wavelength is some strategy that sometimes you don't have a problem that is so easy like this one, have more things around, so that can help you analyze and select the correct answer. So if you are following the test that you have with you, you know that 18 is a repetition of the question 16, so we are going to skip this one. Question 19. The period of electromagnetic wave is 1 nanoseconds. What are the frequency and wavelength of the wave? First, let's calculate the frequency. So the period is in nanoseconds. So a nano is 10 to the minus 9 second. The period is the inverse of a frequency, and the frequency is inverse of a period. So the frequency is, the one that we are looking for, is 1 over the period, which is 1 times 10 to negative 9 seconds, which is 1 times, when you flip, is 1 times 10 to 9 hertz. Okay, so we found here at C 1 times 10 to the 9 hertz. This dash is not over hertz, it's just explaining the unit for frequency is hertz, and here is the unit for wavelength is meter. To find the wavelength for this wave, we are using the wave formula, which is the speed of the wave is the wavelength times the frequency. So we are looking for the wavelength, so we arrange the formula in terms of the wavelength, which is the speed divided by frequency. The problem is, what is the speed of this wave? Well, is given here is electromagnetic wave. All electromagnetic waves, they travel with the speed of light. So the V is C. That's the symbol for the speed of light, which is 3 times 10 to the 8 meters per second. Bingo. So we have that information. So the wavelength is 3 times 10 to the 8, and the frequency is 1 times 10 to the 9. So what is the result? 3EE8 divided by 1EE9, 0.3 meter. So this question here is checking if you know how to expand when you have a prefix nano to the 10 power type of expression, and that if you know the relationship between frequency and period, because that's what it's asking here. And also if you know that all electromagnetic waves, they travel with the speed of light, which is 3 times 10 to the 8 meters per second. That includes visible light, radio waves, X-rays, gamma rays, infrared, UV rays. They all travel with the same speed. So once you know this, you can easily calculate the wavelength of this wave. Last problem. X and Y are 2 points on the surface of water in a ripple tank. So that's a wave on the surface of water produced by a wave generator right here. A source of wave of constant frequency begins to generate waves, which then travel past X and Y, causing them to oscillate. So the question is, what is the difference between X and Y? So the difference between X and Y, and the options, all options are in terms of an angle. So let's take a look to determine what is the difference in angle between X and Y. First, let's take a look on this wave. So if this wave starts right here, so we have at 0 degrees in terms of angle, 0 degrees, and this is our 360 degrees, one complete cycle. So let's look at this oscillation in terms of this circle where we start here and we are moving counterclockwise this way and we finish right here. So the angular direction, you'll be like start with 0, this is 90, that is 1/4 of this complete cycle. You see that? 0, 90, and then we are right here now is 180. So half of this path is gone. Now we go right here is 270, 3/4, and then we finish right here, which is our 360 degrees. So start with 0, 90, 180, 270, and 360. So likewise, if this wave is moving this direction, so we start with 0 and we end at 360, just like we did here, but just like in a horizontal view now on this, in a horizontal view of this. It's like that we have two semicircle of this motion. So now we have 0 here, so 1/4 pass by, 1/4, because this wave we can separate in 4 quarters, 1, 2, 3, 4. 1/4 pass by, oops, now we are here on 90. Now half pass by, we are here on 180. 3/4 pass by, we are right here, 270, and this is 360. Now let's relate this to our problem. So this distance between both crests is one complete wavelength. So each quarter of this wavelength represents 90 degrees. 90, 90, 90, and 90 here. And we have a complete 360 degrees between here and here. However, the problem is asking between X and Y. So we have here 1, 2, 3. 3 times 90 is 270 degrees. So this is the final answer for this problem.